In this lesson, we will begin looking at logarithmic functions and their graphs. Definition: the inverse of the exponential function f of x equals b raised to the power x is called a logarithmic function with base b and is denoted f inverse of x equals log to the base b of x. The logarithmic function y equals log to the base b of x can also be expressed in the form x equals b raised to the power y. Some memory tricks for changing forms are: a log is an exponent, and look for the base when changing between logarithmic and exponential form. Let's express the equations in the other form, starting with the equation 4 raised to the power of negative 3 equals 1/64. This equation is in exponential form. We want to change it to logarithmic form. I'll start by looking for the base. Here the base 4 is raised to the exponent of negative 3, so I'll write log to the base 4. I'll leave some space, put an equal sign, and to the right of the equal sign, a log is an exponent, so I'll put my exponent of negative 3 to the right of the equal sign, filling in with the argument of 1/64, and I have log to the base 4 of 1/64 equals negative 3. Next, let's change the logarithmic form of log to the base 5 of 125 equals 3 into exponential form. I'll start by looking for the base. Here it's 5, so I have the base 5 raised to the exponent. Log is an exponent, so the exponent is 3, and 5 raised to the power of 3 equals 125 is my equation in exponential form. Next, we'll graph y equals log to the base 2 of x by first changing the function into exponential form of x equals 2 raised to the power of y. I will choose three y values of negative 1, 0, and 1 as the y coordinates of the 3 points I plan to plot on the graph. Starting with a y value of negative 1, x will be equal to 2 raised to the power of negative 1, or 1/2. If y equals 0, x will equal 2 raised to the 0, or 1. If y equals 1, x will equal 2 raised to the power of 1, or 2. We'll plot these 3 points, 1/2, negative 1, 1, 0, and 2, 1 on the graph. Connect with a nice smooth curve. This is a graph of y equals log to the base 2 of x. Note that as x approaches 0, y is approaching negative infinity. As x approaches infinity, y is also approaching infinity. The domain here is x values greater than 0. The range is all values of y, negative infinity to infinity. I have a vertical asymptote this time of x equals 0, and also note that the point 1, 0 is on the graph. These properties apply to all logarithmic functions. Next, let's look at the common logarithm. Log of x, log with x in parentheses, is equal to log to the base 10 of x. Let's also look at the natural logarithm, which is ln, x in parentheses. We pronounce it as the natural log of x. It's equal to log to the base e of x. And I will graph y equals the natural log of x by first of all rewriting y equals natural log of x is y equals log to the base e of x, and then changing form so that we have x equals e raised to the power of y. Let's plot some points for the graph by again using the y coordinates of negative 1, 0, and 1. This gives me x values of e raised to the negative 1, which would be 1/e, e raised to the 0, which is 1, and e raised to the 1, which is e. I'll plot the points 1/e, negative 1, 1, 0, and e1 on the graph. Connect with a nice smooth curve. And this is a graph of y equals natural log of x, another graph you should be able to quickly sketch on your own when you need to. Let's sketch the inverse functions y equals e to the x and y equals natural log of x. Here's y equals natural log of x. Here's y equals e to the x. And let's also sketch a graph of the line y equals x. Note that these graphs, y equals e to the x and y equals natural log of x, are reflections of each other about the line y equals x. Another confirmation that these are inverse functions. Try on your own. Sketch the graph of f of x equals log to the base 4 of x.